Welcome to aminacademy.com. In astronomy, let us discuss about spectroscopy in astronomy. Electromagnetic radiation carries a lot of information about the nature of stars and other astronomical objects. To extract this information, however, astronomers must be able to study the amount of energy we receive at different wavelengths of light in fine detail. Here we will describe about the properties of light, explain how astronomers learn the composition of gas by examining its special lines, discuss various types of spectra. Astronomical spectroscopy is the study of astronomy using the techniques of spectroscopy to measure the spectrum of electromagnetic radiation including visible light, ultraviolet, X-ray, infrared and radio waves that radiate from stars and other celestial objects. Properties of light. Light exhibits certain behavior that are important to the design of telescopes and other instruments. For example, light can be reflected from a surface. If the surface is smooth and shiny, as with a mirror, the direction of the reflected light beam can be calculated accurately from knowledge of the shape of the reflecting surface. Light is also bent or refracted when it passes from one kind of transparent material into another, say from the air into a glass lens. Reflection and refraction of light are the basic properties that make possible for all optical instruments devices that helps us to see the things better, from eyeglass to giant astronomical telescopes. Such instruments are generally combination of glass lenses which bend light according to the principles of refraction and curved mirrors. Now, let us discuss the points on the properties of light. Light is an electromagnetic wave. Light travels in a straight line. It can bend also by using some instruments. Light is transverse wave and does not need a medium to travel. Light can travel through vacuum. Its speed is 3 into 10 raised to 8 meter per second. The speed of light changes as it moves from one medium to another. The wavelength lambda of light changes when passing from one medium to another. Frequency of f of a light wave remains the same in all media. Even it pass through air or some other medium, the frequency is same. Light is reflected back from polished surface such as mirrors, polished metal surfaces, etc. Now three more properties of light. Light undergoes refraction, that is bending of refraction is a bending of light as it travels from one transparent medium to another. Light does not need a material medium to travel, that is, it can also travel through a vacuum. Scientists have given the speed of the light in a vacuum as nearly about 3 lakh km per second. According to current scientific theories, no particles of matter can travel faster than the speed of the light in a vacuum. Next, refraction. What is refraction? Refraction through a triangular prism. Look at here. Here, a white light passes through a triangular prism in one surface and it's dispersed in different colors regarding their wavelengths. It's dispersed as 7 colors basically. Surface is called the angle between its two lateral surfaces is called the angle of a prism A. The refraction of light through a prism occurs in the way shown in the figure here. The light ray seems to bend towards the normal on entering the prism at the surface AB. Now we'll discuss about spectrum lines. What is stellar spectra. Stellar spectra is an important tool for studying stars. Here, most things in most things in astronomy, by using stellar spectra, they studied more. A hot dense object or a hot gas at high pressure emits a continuous spectrum. That is, if hot and dense object, it automatically emits a continuous spectrum. Spectrum of a thin hot gas is an emission spectrum. Bright lines on a dark background. The lines are characteristics of the gas. Now we'll discuss about types of spectrum. Here, there are three different types of spectra. That is a continuous spectrum formed when a solid or very dense gas gives off radiation, is an array of all wavelengths or colors of the rainbow. A continuous spectrum can serve as a backdrop from which the atoms of much less dense gas can absorb light. A dark line or absorption spectrum consists of a series or pattern of dark lines, missing colors, superimposed upon the continuous spectrum of a source. A bright line or emission spectrum appears as a pattern or series of bright lines. It consists of light in which only certain discrete wavelengths are present. Now, for the discussion about types of spectrum, information about stars and galaxies is collected by observing the radiation and they emit through the spectral analysis. Spectroscopy is the process of splitting a different wavelengths of a radiation apart. Splitting a ray different wavelengths of radiation apart. The spectra are a result of electrons absorbing or emitting energy as they change energy states. There are several types of spectra which can be studied when observing celestial bodies. First is emission, that is nebulae and quasars. Absorption, the atmosphere of stars. Continuous black body used to observe galaxies and the inner layers of stars. These are figures for continuous spectra is like, emission spectra is here, absorption spectra is like this. What is emission spectra? Electrons can exist in discrete energy level called shells. We know that. When a gas is heated, electrons absorb energy and move to higher energy states. The electrons don't last long in these higher energy states before falling back down to their original state. Energy will be released when this electron drops down to a lower energy state. The energy that is released will corresponds to light of specific frequency. Electrons can exist in and move between multiple energy states, and this can result in a large number of light bands being observed on an emission spectrum. Here, sample of emission spectrum. Hydrogen emission spectrum is like helium, lithium, oxygen, carbon, nitrogen, neon. These are important gases in atmosphere. Next is what is absorption spectra. When a light with a continuous spectrum passes through the gas, most of the light will pass straight through the undisturbed. Most of the light pass through it in undisturbed manner. That continuous spectrum will produced. Electrons that are in the gas can absorb energy that is of a specific value, that is a wavelength and frequency. The particular energies that are absorbed are unique to each elements. The energy is absorbed as electrons move to higher energy states. The electron will soon move back to a lower energy state and releases the same amount of energy they absorb. However, when this occurs, the energy is re-emitted in all directions. This results in only a fraction of the original energy being emitted in the direction of the observer. This smaller amount of energy appear as dark bands on absorption spectra. The energies that have been absorbed indicate the elements that light has passed through. Here, look at this is the band with wavelength in nanometer. This wavelength is increased manner, so it is violet to red, it changes. Due to that increasing wavelength is decreased frequencies. Next one, complete continuous black body spectrum. What is that? Hot bodies like lava, heated metals, tungsten filaments, and stars all emit a continuous spectrum of radiation. They emit radiation at all wavelengths or frequencies. The intensity of the radiation varies for different wavelengths. A graph of intensity versus wavelength is known as Planck curve. The shape of the graph depends on the temperature of body and not the material it is made from. Only it depends on the temperature of the body. Each Planck's graph has a characteristic peak intensity that corresponds to a certain wavelength. This wavelength can be applied with Wien's law to determine the temperature of that body. Here, this is a visible light shows in this. Here, this wavelength near to 500 nanometers. Look at here. That intensity goes some extreme level and come back. Within some temperature, it come back to lower intensities or lower intensities. Here, different curves look. So here have its own peak point. Often it is difficult to distinguish between galaxies, stars, or clouds of a gas or nebulae. Observing the spectrum of these objects can help us identify what is that of we are looking at. If the spectrum is an absorption spectrum, we know that it is produced by stars. If it is absorption spectrum, it is produced by stars. If it is an emission spectrum, we know that it is produced by diffuse clouds and gas. Emission spectrum diffused by clouds and gases. Next is, if it is emission spectrum, we know that it is produced by diffuse clouds and gases. Next, we will discuss what is a rainbow. A rainbow is very interesting fact. A rainbow is an optical phenomenon caused by refraction, internal reflection and dispersion of light in water droplets, resulting in a continuous spectrum of light appearing in the sky. This is a rainbow, very nice looking here. The rainbow takes the form of multicolored circular arc. A rainbow caused by a sunlight always appear in the section of sky directly opposite to the sun. Rainbows can be caused by many forms in airborne water. These include not only in rain but also mist, spray, and airborne dew. Rainbow can be full circles. However, the observer normally see only an arc formed by illuminated droplets above the ground and centered on a line from the sun to the observer's eye. In primary rainbow, the arc shows red on the outer part of the violet outer part and violet on the inner side. This rainbow is caused by light being refracted when entering a droplets of water, then reflected inside on the back of the droplets and refracted again when leaving it. The double rainbow, that means a second arc, is seen outside the primary arc and has the orders of its colors reversed with red on the inner side of the arc. This is caused by the light being reflected twice on the inside of the droplets before leaving it. The rainbows are an excellent illustration of the dispersion of sunlight. You have a good chance of seeing a rainbow anytime you are between the sun and the rain shower. So far we discussed about that dispersion, absorption and continuous emission, continuous emission and absorption. As well we discussed type of spectra, stellar, what is stellar spectra. As well we discussed about properties of light and what is astronomical spectroscopy in detail. We have done. Please subscribe our YouTube channel.